commands. So, as you know, for our knowledge purpose, I will go through the Kubernetes deployment documentations. And from the documentation itself, we'll try all of the codes, all of the commands in the killer coda playgrounds. So for that, okay. So now we have the CK playground with us. It will take some time. Let's wait. Okay. So let's start. So in this particular playground, we will have all the CKA, CKS, and CCAT aliases. Just I will type kubectl get pu. Sorry, kubectl get pu. So it's saying like no resources found in that default namespace. And the same command I can type as with alias of kubectl get pu. It will give you the same answer. So just like that, the alias for kubectl is already set to k. So we can go ahead with that. So let's go to the deployment. A deployment manages a set of pods to run an application workload, usually one that doesn't maintain state. So, suppose we want to run a bunch of applications and we want the availability as well. So, what I can do, I can run 10 or hundreds of replicas of my particular application, which is running as a pod, and that pod will have multiple replicas, and a deployment also provides declarative updates from pods and replica sets. So, the next line you can see, you describe a desired state in deployment and the deployment controller. So, as we know that we have multiple types of controllers over here using in Kubernetes, and yeah, under the hood they are working as per their potentials. So, the deployment controller changes the actual state to the desired state. So suppose now I have the desired state, it's 4, but before that I have the desired state as 3 because I have mentioned my replica set as 3 while creating the deployment. But after some times, I just think I have to increase my desired state to 4 or 5 like that. So at that moment, the deployment controller changes the actual state to that desired state at a control rate, and you can define the deployments to create new replica set or to remove existing deployment and adopt all the resources with new deployments. Let's go to the note point. Do not manage replica sets owned by a deployment. Consider opening an issue in the main Kubernetes repository. Okay, just ignore that. So, but yeah, this line we have to be very careful. Do not manage the replica sets owned by a deployment. So, under the hood, when we are creating the deployment, it is creating a replica set to manage all the pods owned by that particular deployment. We will get some of the examples later in this section. So let's go to the use cases. Like basically, if we'll go through the documents, we will get the updated informations. So that's why I choose this path. So hope it will be helpful for you. So the first use case is like create a deployment to roll out a replica set. The replica set creates pod in background, blah blah blah. All those things I already have told you. Next, go to the second point, declare the new state of the pods. So suppose I'm running on Nginx pod, which is having the version of Nginx as 2.14.1 -alpine. But sometimes I got a new update with the version of 2.16.1. hyphen alpine. So I just have to update that image, and the same thing can be done by the deployment without like going and changing the whole manifest of the deployment file, but I can just simply set the image to the updated one. So that's a handy trick what deployment offers in Kubernetes. Then roll back to an earlier deployment revision. As it mentioned from its state, it's quite obvious. Suppose the new version, or whatever, the current state currently I have deployed, is not stable. The version 1.16.1 hyphen alpine is not very much stable. So, our teammates came and reported that issue. So, what I did, like as a DevOps engineer, I can just roll it back. Roll back the updates, and also we can keep the revisions history of that particular deployment. So we have that command for all the deployment, the rollback status and rollback history commands. We can go through that later. So the next point, scale up the deployment to facilitate more load. It's like the we can say about the auto scaling part, and then we can pause the rollout of a deployment again. We can resume that. As the reason says, to apply multiple fixes to its pod template spec. So don't worry about that pod template spec. So it's just like we can say the annotations handling by Kubernetes, and mostly you can see that in a JSON format. So and after that, the pausing that particular deployment, we can resume it, and it will start a new rollout. So coming to the next point, use the status of the deployment as an indicator that rollout has stuck. Yeah, if something goes wrong, it will show us like, okay, this is in pending state. And there is a very interesting point about that. I can go through the other documents related to that, and then we will get a clarification on that, and clean up older replicas that you don't need anymore. So basically, it's like up to 10 revision versions like we can store. So these are the theory parts of the use cases. So let's do some hands-on, or we can go to our create deployment. So we have here the manifest file for the deployment. I can do in declarative way and in the imperative way. So just to clarify that, I can just copy this particular deployment and create a deployment out of it. I have just copied it, and I will go to here. I can create one for YAML file for deployment. Let's paste our the deployment manifest. So over here we have given the API version is apps v1 kind deployment metadata with the name and labels and the spec. So in all the Kubernetes objects we have API version kind metadata and spec. And inside the spec of deployment, we have replica selector and template. So these are the mandatory things. We have to mention the replicas, we have to mention the selected, so that the match labels, whatever the like a key and value pair we are starting with, all we are giving. That same can be found in the pod template, this particular block, this template block, we can say is exactly as pod's template. So only we can mention the containers, and if you want to open some ports, and if you want to pass some commands over here, so you can do that. So let's save this one, and we can create our deployment. out of this deploy.yaml file. For that, I can go ahead with the command to create a deployment. So kubectl, instead of kubectl, I can simply write k create deploy. We can write deploy or deployment. Both can be like work. Kubectl create deploy and the deployment name whatever like we have given, or else like okay, we can do one thing simply like kubectl apply -f with the deploy.yaml file. So now our deployment is created. I will check. Okay, we have the deployment named Nginx deployment. It's having three replicas. So this is 3 out of 3. That means the desired and actual state is 3. And sometimes it will, if the deployment is going through some rough conditions, it will be like 0 out of 3. So none of the pods are currently running, and up to date is showing 3 because we have not done any changes, and this is the up to date state, and available is 3, and age is showing is 9 seconds. So you might remember I was telling whenever we are creating a deployment under the hood, it's creating replica sets, and that replica sets actually handles all the pods inside the deployment. Let's have a look into that. So I will check for the replica set. Okay, get RS. So RS stands for the replica set in Kubernetes. It says shortcut, or we can say it's alias. So now I can get my replica set. So if we'll look a little bit closely, this Nginx deployment is the deployment name, and the replica set name is Nginx deployment, and with some hash value. So it is always you can find that whenever you are creating a deployment, a new replica set will be created with the particular deployment name added with some hash value. And also a very interesting point is that if I will do get pu, it will give me all the pods. So here also you can see the pod having the name Nginx deployment with some hash value, again with some hash value. So up to this, I can see all the 3 having same hash value, same name. But in this later part, it is getting some deviations. And if you will notice, this particular name is exactly same as the replica set name. Okay, so I hope you are getting the point why I'm explaining this. So now we are having our deployment, replica set, and pods. Let's get back to our documentation page. And in this example, a deployment named Nginx deployment is getting created, indicated by the metadata.name field. So these are all like we can say the JSON formats. Like whenever the Kubernetes API hits, whenever we apply the kubectl apply command, then it directly will hit to the kubeconfig. It will grasp all those I mean the configs, and then it will hit to the Kubernetes kube server API, and then it will work with all different types of controllers, and after that it will create our resources. So this name will be basis of the replica set and pods which are created later. See writing a deployment spec for more details. It's not required. The deployment creates a replica set that creates 3 replicated pods. So as we have seen, there are 3 replicated pods, and the spec.selected. So selected and match labels we have uh, okay, let's go to the describe deploy deployment apps, and then slash nginx deployment. So in the describe command, it will give us all the details of that particular deployment, the name, the namespace, because we have not mentioned any particular namespace. Obviously, it will take the default one. And then the labels, annotations, and selector equal to nginx, and the replicas, 3 desired, 3 updated, 3 total, 3 available, and 2 unavailable. And this is like the strategy type. It is having rolling update, and this is the default one. And we have the rolling update strategy, 25% maximum unavailable and 25% max search. That means suppose we have 100 parts, so at a time the maximum unavailable parts will be 75, and at a time again it can go up to 125. That depends on those conditions and how you apply that. But 25 max unavailable and 25 max certs is the default one what is provided by the deployment. And in the pod template, you can see the same label as the selector has app equal to nginx as labels. So by this way, the replica set or the deployment checks which pods they have to work on, or which particular pods coming under their territory, we can say in that way. And in the containers we have the images as like mentioned 1.14.2, and here we have the conditions sometimes you can see the region. This region also you can get in the JSON format. So you can see the new replica set, nginx 3 out of 3 replicas created. And in the last the events, it will show us scaled up the replica set nginx deployment with some hash value to 3, because we have the replica set is 3. Okay, then let's go to the command. We already have created the deployment, and kubectl get deployment. We already have that command in our killer coda, and we already have the value. So let's go to the next section to see the deployment rollout status. If you remember, I was telling you some rollout status about that kubectl command. So kubectl rollout status, deployment, and then followed by the deployment name. So we can go to our, let's clear it. Rollout status, and then the deployment followed by the deployment name. Okay, the deployment nginx deployment successfully rolled out. And also you can do the same thing by replacing the status. We can give history. Okay, so it is showing as revision as 1, and the change codes is none. And also just remember that we can pass some value, whatever the message. If we want to pass some message, we can pass that message while doing the deployment or the rolling out, and the same message we can see in the change codes. So let's go to our replica set to see the replica set. We can see like this. And you guys can go through all those parameters. These are like simply what exactly this particular headings is like meant for. And I don't think it's required to go through all those particular headings. And yeah, as I mentioned, to see the labels automatically generated in each pod, like if we'll go to the replica set ending with 897, and here also ending with 897, all the 3 pods are ending with 897 with again some hash value which segregate them all the pod from each other. Okay, so let's go to the note. You must specify an appropriate selector and pod template labels in a deployment. In this case, it is app. colon nginx. Here the app is the value, sorry, key, and the nginx is the value. So we will have a key and value pair in our labels and match selectors. Do not overlap the labels or selectors with other controllers, including other deployments and stateful sets. Okay, that's obvious. And Kubernetes doesn't stop you from overlapping. And if multiple controllers have overlapping selectors, those controllers might conflict and behave unexpectedly. Okay, so now we have the pod template has label. And there is a caution over here, you can see do not change this label, because under the hood, while it is fetching the values from like in the internal server, we have that pod template has. So this is added by deployment controller to every replica set that a deployment creates or adopts. This level ensures that the child replica set of a deployment, that means like whenever we are creating a deployment, automatically it creates a replica set. That means the child replica set of a deployment do not overlap. And this particular thing has to be taken care by this label. If you're giving the label and selectors in a proper way, it will ensure that it won't overlap. And it is generated by hashing the pod template of the replica set and using the resulting hash in as the level value that is added to the replica set selector. Pod template levels in existing pods that replica set might have. So, it's we cannot go through this by just beating around the bush. But the main point, we have to be very cautious about the levels and selectors, and within because it depends it won't overlap, and different controllers working simultaneously will not get some conflict in between themselves. So updating the deployment. Okay, in meanwhile, I think I forgot to mention about the imperative command. So what I will do, let's clear it. So now I can check like what is the deployment number available in our cluster, and let's check like what are the nodes. Okay, we have two nodes, control plane and node 1, and we have one deployment called nginx deployment. So now I will do like kubectl create deploy. You can write as deployment or deploy, anything can be fine. Then the deployment name, my deploy, and I will give like the images equal to I can say busybox. And what else I can give? I can specify the replicas 4. Okay. I am getting one error. C kubectl create deployment -hyphen help. Let's go to the same command. Let's run that. And by this, we can get a useful handbook of that Kubernetes. Okay. So, what mistake I have done? It is like it has to be image, not images. So, I have to rectify my command when deleting the errors, and then I can see the deployment has been created. And now, if I will check, okay, get rs. So now see, there are two replica sets and one replica set having name with my deploy, which is a deployment, which is the new deployment I have recently created. Let's go to the pod. So now I have 7 replicas, and 4 of them from my deploy. And okay, let's go. If I can count that. Okay, let's leave that. Now our point is like we have 3 replicas and we have 4 replicas newly created. Let's again go to the pods. So it is showing like crash loop backup. There might be some issue with that particular image. So if I want to check that, I can go to like okay, describe PO, and with that part I can go with this part. So okay, now I can see the messages, or else like I can say it's the event successfully assigned, successfully pulled that image and created the container PG box. Okay, so now what is like it's telling like it created the container, image got pulled, then it created the container, then it started running the container, and then it got deleted. So it's basically the container lifespan or container life cycle, we can say. Because I have why it happened, exactly why it happened, that's a question for you. If you guys can like uh, answer the question, that's very good. Else to explain, I am just giving one example. I will run krun pod 1 and have an image. I can give easy box. Pod is created. So now I am having the pod 1. It's 0 out of 1. Again I will do. So it's throwing me a error like crash loop back off. Okay, for that I have given correct only. Let's delete the pod. Okay, delete PO pod 1, and instead of busybox I can check Nginx. Let's get the pods container creating. Okay, now the pod 1 is running. Okay, and again I will create one pod. Okay, run PO, and then our okay, I can give pod 101. BC box, it's getting created. Get PO, it's showing now completed. Okay, so what I will do, I will run. Okay, run. This is pod 202 hyphen image with BC box, and after that I will give command. Okay, now it is getting created. So we can just wait for a few minutes. Now I can see like it is showing as completed. That means like it just pulled that image, run that container, exit from that container runtime, and then it is in completed state. Like the strategy is showing is completed. And again, when I did it again in the second time, it again coming as like crash loop backoff. This particular like crash loop backoff is having a different concept, like why, but this particular error is coming. We can see that later. Again, it is showing as completed like that. So this is like when I'm giving with this command with sleep. Okay, I have done that command in the wrong way. So 202, let's delete it. I have this command as this, and then I get PO. So see, the pod 202 is still running. And previously it was showing sometimes crash loop back off the 101, and sometimes like because both of them are having the same image. Uh, okay, it's already in the table state. So okay, let's not deviate from that main topic with the deployment. So I can just like the same way I am doing that image. I am updating that image. I can update the image for our uh, deployment. A deployment rollout. Okay, so just give a little bit focus on this particular note. A deployment rollout is triggered if and only if the deployment spot template is changed, and within that, that is spec.template. And for example, if the labels or container images of that template are updated, only the labels or container images of that particular template are updated. Other updates, such as the scaling of the deployment, do not trigger a rollout. So, let's do with the hands-on. We'll follow the steps simply, and let's up. Okay, so let's check in the first step. It is to what exactly it is doing. It is updating the Nginx pods to use Nginx 1.16.1 images instead of 1.14.2. So I'm clearing my screen. Okay, get deploy. I have two deployments. Then I will delete my deployment. My deploy deleted. Now I will have only one deploy, Nginx deployment, and let's describe it. Nginx deployment. So here I can see the image name is port over Nginx colon 1.14.2. So now I have what I can do. I have to change. Like I will change my. Let's emphasize on again this one. For example, if the labels or container images. So now I'm going to change the container images. So okay, set image, and then I will take the deployment. Okay, we have two options: deployment.v1.apps, and this you can see like in the starting, from the starting where we have our deployment manifest apps.v1. This is the API version. So like as I told, like whatever the kubectl apply command or kubectl command we are applying or writing in our command line, it is throwing it is going via the kube server with a JSON get or post methods in the API sections. So now When I will do that, kubectl set image for the deployment and set image, I will go with the deployments. And then what is the deployment name? I can give it like the deployment name. Okay, so we have two options: deployment name, or else like deployment dot v1 dot apps, then deployment name. So you can also give a backslash like this, and then the image version. So what is the image name? Our image is like Nginx equal to Nginx 1. Previously we have 1.14.2. Now I have 1.16.1. I'm just doing thoroughly because just if you guys will try this out, it will be a very track record kind of thing. So I'm not deviating from the commands whatever is present over in the documents, because that is the file, that is the documentation I'm going to follow, and it will give a clean record. Okay, the image has been updated. So now, okay, let's go to the document and find it where we have to emphasize. Where the deployment indicates the deployment, Nginx indicates the deployment, and Nginx indicates the container the update will take place. I mean, that particular container where the update will be happening will the image versions will be updated for the container images. Nginx colon 1.16.1 indicates the new image and its tag. So the output will be like the image updated. As you see, it is getting like deployment.app apps then slash nginx deployment. This is the deployment name we have, nginx deployment image updated. And then we can also alternative way we can do kubectl edit command. That also I will like so how we can do that. And to see sorry, to see the rollout status, we can see the rollout status as well. Rollout status, deployment, and then Nginx, sorry, Nginx deployment. So it's been successfully rolled out. Also, we can give, okay, the dollar echo command is not working. Okay, we'll see that later. Uh, the output is similar to this is edited. Okay, this edit part also I will continue in some time, but before that I just want to show you few things. Oh yeah, exactly this one. So as I told you, whenever I will create a new deployment or do some update or do some changes, it will create a replica set under the hood, which I mean, which replica set will manage the pods. So run kubectl get rs. So rs stands for the replica set to see the deployment updated the pods by creating a new replica set and scaling up to 3 replicas, as well as scaling down the old replica set to 0 replicas. Let's go to our terminal. We have 2 replica sets. So previously, when we had our pods that will be like before 28 minutes, it will have like 558 with it. But now the replica sets coming with 9CF, and now if I will check on the pods also, this will having 9CF. It will not like the 5581. So we have now the new replicas, and it is working as with that, or like along with that same has value with the replica set. So this was the main point I want to highlight, and we have pending with the kubectl edit command. Okay, kubectl edit deployment. Let's go to first. Let's clear that, and then so now we have our in the deployment we have our version 1.16.1. So again we will do that like 1.14.1. Okay, so okay, edit deployment, and then Nginx deployment. It will open up the VI editor. For that we can go to insert mode, and now I will do as now the image version is 1.16.1, and I will convert it, I will change it to 14. Let's save, and then it is saying that Nginx deployment got edited. So now let's check. Okay, we have again one more new replica just 11 seconds ago. So this is again like I have changed my image versions. So if I might have changed the replica words, I mean the replica numbers, the replicas equal to 4 or 5 or something like that. Okay, so at that moment it won't change it won't create a replica because that is not related to the image labels. Then this edit part also completed. Let's go to some different concepts. This maximum and max search and is 125, and that max unavailable will be like 20%, 25%. That means if you will take the example of 100, it will 75 or 125 like that. This example already have given you. And okay, for example, we can check with this particular nodes. If you look at the above development closely, you will see that first it creates a new pod and then deletes an old pod and creates another new one. It does not kill the old pod until a sufficient amount of, I mean, sufficient number of new pods come up, and doesn't create new pods until a sufficient of old pods have been killed. It makes sure that at least 3 pods are available, and the max 4 pods are in totally available. It has to be because we have set our max unavailable and max search 25%. So it is adhering to that particular conditions. And in the deployment scriptural describe deployment, we can have that all the descriptions of that. And if we'll see that, okay, we can see is the same thing. Okay, describe deployment. Okay, sorry for the mistake. Deployment and Nginx deployment. So first it's scaled up the replica set, which is the first one 32 minutes ago, and the recent one like 2.38 minutes when I did. First it scaled down the replica set Nginx, I mean this the new one 9CF to 2 from 3, and again the deployment controller scaled up the replica set, which is the new one 8C7 from 2 to 1. So in this way we can just cross verify like how it is behaving. And the deployment have the numbers Nginx deployment with this has a value. This particular thing we already have discussed, and we can go to our rollover. Okay, that is we can say multiple updates in flight. And So we can go to the example section, and suppose you create a deployment to create 5 replicas of for this particular version, and then update the deployment to create 5 replicas of this version suddenly. And when 3 replicas of this version, that means whatever the first image version you have given in the first command had been created, in that case, the deployment immediately starts killing the 3 old replicas, the old image versions, the pods which are getting created with the old image versions, and it will start deleting and again starts creating the new pods with the new versions. And the main point is it doesn't wait for the 5 replicas of this particular old version to be created before changing the codes. So this is quite a bit tricky concept, like we can say, to going under the hood, how exactly it is managing. Suppose like I'm running one command and again I'm stopping it and running a different command. Okay, so under the hood, it will obviously take the latest one instead of, like, suppose if from the previous one also it got created already created 3 pods. So immediately it will terminate all those pods. Instead of waiting, it doesn't wait till the 5 replicas of the older version is going to be completed. It directly will take the action. And the label and selectors, we already have discussed. And if you want a brief discussion about the labels and selectors, we can have a different session on that. And then we can have the rolling back options. So the same scenario, like sometimes you might want a rollback for a deployment when the deployment is not stable, such as crash looping, and by default all the deployments rollout history is kept in the system so that you can roll back anytime you want. And you can change that by modifying the version history limit. So basically, the default one will be 10. Up to 10 version revision history you can store it. So the next note will be, a deployment's revision is created when a deployment's rollout is triggered. So each and every time we are rolling out, a revision will be created, and this means that the new revision is created even only if the deployment spot template, as we discussed, the template is getting changed. For example, if you update the labels or container images, so for this container images, we already have seen that, but the labels and selectors is not recommended to change because under the hood it's coming under a lot of changes which can be mismanaged, or it will arise in conflicts while the operations inside the Kubernetes. So we generally don't prefer to change the labels and selectors because whatever the new changes, because if I will change the label, and at that particular time, when I create a deployment, it will create a new replica set, and the new replica set will not have those updated labels and selectors, so that whatever the previous pods with those old labels and selectors will not be recognized by that particular replica set. So those kind of conflicts will happen in that case. So it's better to avoid that. But yeah, we already have seen that container images, like updating the container images up in the template. So other updates like scaling down, scaling up the deployments just by hitting the replicas point. The replicas number. So it's not creating, in that case, it's not creating any deployment revision version. So let's go to the next part. Suppose you made a typo while updating the deployment by putting some images as Nginx 1.161. Okay, that's interesting. Let's go to that our CLI, and let's copy this and run that. So now it's created. Let's check for the deployment, and it is showing as 3 out of 3. Okay, describe deployment, Nginx deployment. Okay, now I can see the image version is showing is one Nginx colon 1.6 point, sorry, 1.161. Okay, and after that, the rollout got stuck. kubectl rollout status. So let's check the deploy and okay, rollout status and then deployment and then Nginx deployment. It is saying waiting for a deployment to roll out or Nginx deployment to roll out to finish. One out of three new replicas have been updated and it is still in the pending state. So let's hit Control C. So the output is similar to this. Yeah, it's same only. And we can you see the number of old replicas, adding the replicas from Nginx deployment, this has value is the old one, and this is 3, and the number of new replicas from this is 1. Okay, so let's check with the replica set. Okay, so the same result we are seeing in our kubectl command. So looking at the pod created, you see one pod created by new replicas is stuck and in an image pool loop. So let's go and do the pods. Okay, so this pod 202 what we have created, so don't focus on that one, but yeah, image pool back off. So as we see here, looking at the pods created, you see one pod created by new replica set is stuck in an image pool loop. Yeah, it's stuck only. And as we mentioned or as we discussed previously, if something goes wrong, it will immediately stop creating the pods. It will hold. So yeah, we have similar kind of output over here, just like the highlighted part. Let's go to the node part. So the deployment controller stops the bed rollout automatically and stops scaling up the new replica set. This depends on the rolling update parameters makes unavailable specifically, and that you have specific in the Kubernetes by default sets to 25%. And then get the description of the Kubernetes deployment, describe deployment. We already have seen that. Checking the rollout history of the deployment. So if we will go with the rollout history, rollout history, and then deployment, and then Nginx deployment. So it is showing as we already have done. There are 4 revisions available, and we can give a few of the changes why it happened or what is the custom image custom messages we want to give, that also we can give. And this you can see the kubectl rollout history and this particular revision number. So let's run that, and revision equal to 2. Let's go to 2. Here we have 16.1. So in the revision 1 we had 14.2. In the revision 3 we had again 14.1, but in the revision 4 we had 1.161. So like the same way we can see what is the in what revision what changes we have been maintaining. And okay, for these rolling back to a previous version, all those topics we can discuss in a different video. So let's hope this particular session is useful for you. I hope whatever the doubts coming to your mind, I've cleared those. Thank you. Thanks for watching.